Hey, welcome back. Daily Shia, daily life, daily science, daily math. One day at a time, learning new things. We are still beginning algebra. And we just learned about mixed numbers. So if you remember, that was that whole, you've got one number that's not a fraction, and then you've got another number that is a fraction, and they're put together in this way. And this just means that this number is added to this number. So it's the sum of a natural number and a proper fraction, if we're being technical. That's the definition of a mixed number. Now we are going to learn some more definitions. This will help us when we start manipulating our numbers and equations. So we do need to learn all these terminologies and what they mean. And this actually is a great point that I want to make about in math generally. And that's that while there are often definite ways of finding the answer to a problem, the mechanics are based on the definitions, like the rules that we are learning. And so it'll be sort of important to learn the terminologies as well as the mechanics of what we're doing as we continue, so that you can get the right answer every time. You know, they're testing you on your ability to use the rules that they are teaching you. So if I say, hey, show me a mixed number, or better yet, if I say, hey, tell me if this is a mixed number or not, you'll say, well, it kind of looks like a mixed number, but I remember from my definitions that a mixed number is a natural number here, followed by a proper fraction. And I also remember that a proper fraction, the numerator should be less than the denominator, and that's not the case here. Therefore, this can't be considered a mixed number. Cool. Let's learn about the definition of a factor. You're going to hear a lot about factors. So hopefully before coming into this, you already have an idea of multiplication, simple multiplication, like 3 times 6. 3 times 6 is 18. And just for that review, we're just saying 6 3 times. 6 plus 6 plus 6. So there's 3 6s that we've added up together, and that equals 18, right? Because 2 6s is 12, and then a 12 and a 6 is 18. Cool. Well, what is a factor? Well, a factor is just really, it's the result of multiplication, right? So if we, well, let me put it this way. There are other ways to get 18 that we are aware of. For example, 18 one time equals 18, which is the same as saying 1 times 18. Now, I know that's seems repetitive and not very reductive, but this is also an important process in math to reconcile with. This factor 1 is a factor of 18, just like 18 is a factor of itself, right? And the result is the product. So when I say, hey, what is the product of 3 and 6, and you say 18, I could also ask you, what are some factors of 18? And you could say 3 and 6. You could also say 1 and 18. Those are all factors of 18. Another one, for example, might be my cat. My cat is here. Might be 2 and 9, right? If I said, what is a product of 2 and 9, you would say 18, because 9 plus 9 equals 18. There's 2 9s, and so there you go. But what if I also said, well, what are more factors of 18? Now you could also say, well, 2 and 9 is a factor of 18. So I've seen this done in a lot of ways, but I think I'm gonna sort of use it's sort of like making like a tree where I start from 18 here. And you don't have to go in order, but I think it makes sense to start with 1 because it turns out that 1 is a factor of any number. So we already did that one. And you could just kind of keep going in this fashion too, because it's an even number. We'll learn some rules as to why this is true. Now 3 is interesting because there's some properties when you have 2 numbers that multiply to be a number. We'll talk a little bit about that rule. And you'll notice something here that if we multiplied this together, we'd actually get the 6, and that's like the 3 times 6 idea, which gives us 18. So again, we'll talk about this expansion thing later, but I just want you to kind of start recognizing some patterns when we start building our factor trees. Okay, so these are all the factors of 18. 1, 2, 3. I'm not going to write 3 twice, even though you'll see like it. We needed 3 times 3 times 2 to equal 18. I'm just going to write it 1 time because it's 3 times 3 that equals 9. But we actually just needed one of the 3s and a 2 to get 6. So those are all the factors of 18. Oh, and 18. Almost forgot. Cool. This book also thinks it's a great time to learn about prime numbers. And I say, sure, why not? We'll tuck that into this lesson too. What is a prime number? Again, these are just definitions for things. So if it's going too fast, just stop, slow down, rewind, write me questions in the comments, and we'll talk about it. But this is just another kind of like number. Remember before we had the natural numbers and the whole numbers, and like there's kind of like a sequence of things that I wrote down that I said like go off into the sunset, meaning they just keep going forever. Prime numbers are also a sequence of numbers, but there's a specific rule. There's like some constriction in that it can only have 2 factors, right? It can only have 1. We know that everything's going to have the factor 1, and it can only have a factor of itself. So like strictly speaking, is 1 a prime number? Well, it's got a factor of 1, which is also the factor of itself. But I think if we're being pedantic, which you kind of have to be in math, we're going to say, well, that's not 2 different numbers. That's just 1 and itself. So like, yeah, a natural number greater than 1 is prime if and only if it has 1 as factors itself and the number 1. So let's think about this. What about 2? Is 2 a prime number? The only factors of 2 using natural numbers is 1 and 2. So 2 is a prime number. What about 3? Again, it's only going to be 1 and 3 that can be factors of 3. that are natural numbers greater than 1. What about 4? Tic-tac, no, not really, because you could have 1 and 4, which follows this pattern, but you could also have 2 and 2, and that would also give you 4. So 4 is not a prime number. What about 5? Yeah, 5 is one of them. There's no other way to give you products of 5 other than 1 and 5. 6? Well, no. I mean, there's the 1 and 6, but there's also the 2 and 3. So 6 is not a prime number. 7? 7 is a prime number. 8? Definitely not 8. I mean, just because we already took out 4 as a candidate, so just the fact that it even has a 4 makes you have to rule out 8, you know, because 2 times 4 gives you 8. So already we know that there's another way to get 8. There's several ways to get 8. 9. Similarly, we already kind of talked about this, right? But then there's also like, there's going to be this idea that there's 3s and there's 1 and 9. So my battery is running low, but you can kind of think about this for a bit. And I'll just write out the first couple in the sequence before we end this lesson. 19, and think about the numbers around these and why they're not prime numbers. And we'll continue on the conversation in the next video. But these are just some numbers in sequence, sort of going from smallest to greatest. But we can keep going. These numbers can get extraordinarily big. And there's some cool stuff in some upper math that deals with these kinds of prime numbers, and computer science as well. Cool. That's it for now. We'll come back and then we'll do some more factorization of numbers.